spend all this time and energy studying elasticity of demand. It's mathematical, it's not immediately intuitive, it's difficult. What's the payoff to you? The payoff is, once you understand the concept of elasticity of demand and how to calculate it, you have a useful tool for predicting the relationship between the price of a product and the total revenue that you earn when you sell your product at that price. Let me give you an example. Have you ever wondered why airline tickets go on sale all the time and appendectomies never do? The answer is this. If airline company ABC puts their airline tickets on sale, they will attract a lot of customers. They'll attract customers from their competitors, and they will attract customers from people who didn't even plan to travel. A small change in the price of tickets brings in a lot of new customers for ABC Airlines. Their total revenue increases because the demand for their product is very price sensitive. On the other hand, the hospital doesn't put its appendectomies on sale because if they cut the price, they wouldn't bring in a lot of customers. People don't buy appendectomies because of the price. They buy them because they need them. And if the price changes, the number of customers that come into the hospital may not change at all. You lower the price of an appendectomy, and all you're going to do is reduce the total revenue that you earn from doing appendectomies. This goes back to an idea that we discussed. That is, the price sensitivity of demand. If demand is price sensitive, a small change in price brings in a lot of new customers and total revenue increases. On the other hand, if demand is not price sensitive, a big increase in the price of the product may not change your customer base at all. You may still sell just as many appendectomies, and total revenue goes up when price goes up. The relationship between elasticity and total revenue is a good reason to learn about elasticity of demand. It's a payoff for learning that difficult concept. What I want to do now is show you in mathematical terms how elasticity of demand and total revenue are related. In order to do that, I'm going to start with a mathematics trick, and you can see this in the box next door. The mathematics trick is this. If you have the product of two numbers, A times B, and you want to know how they change, you can approximate the percentage change in the product, A times B, as equal to the percentage change in the first factor, A, plus the percentage change in the second factor, B. This is a good and very useful approximation that's used all the time in economics. Now, I can't prove this without doing some kind of heavy-duty calculus with logarithms, and you don't want to see me do that. So instead, what I'm going to do is show you in a picture how the proof might look. Suppose we have a diagram with A on the vertical axis and B on the horizontal axis. If you pick a combination of A and B and represent that with a point, the area that is seen in the diagram is the product of A times B. Now suppose you change that area by moving A and moving B. You can add to A by adding height to the box. When you add to B, you add width to the box. And if you look at those two areas, you can see the percentage change in A and the percentage change in B. All that's left out is the little piece up in the corner. But this lets you know that you can take on faith my assertion that the percentage change in the product is equal to the sum of the percentage changes in the components. Now, let's put that to work to understand how elasticity and total revenue are related. What is the formula for total revenue? Well, it's the price of the product times the quantity that a firm sells, P times Q. What's the percentage change in total revenue going to be? Well, the percentage change in total revenue is going to be equal to the percentage change in the price plus the percentage change in the quantity demanded. How do I know that? Well, I just use my math trick. I use P as one variable and Q as the other variable. Now, here's the question I want to ask. If I change the price of the product, we know that quantity demanded changes in the opposite direction. That is, the percentage change in price has the opposite sign from the percentage change in quantity demanded. We know that because the demand curve is downward sloping. When the price goes up, people are willing and able to buy less of the product. What I want to know is, which of these two effects dominates total revenue? Does the price effect dominate? In that case, total revenue and price will move in the same direction. Or does the quantity effect dominate? If it does, then price and total opposite directions. Let's do a little bit of math here, and we'll come up with a familiar expression. Let's suppose then that the percentage change in price plus the percentage change in quantity demanded adds up to a number that's greater than 0. And we're going to suppose that that happens when the price of the good goes up. Now, let's take this equation and mess around with it a little bit. Let's start by taking this term, percentage change in quantity, and moving it over to the other side of the inequality. Now, I got to be real careful with my signs here or I can get confused. I decided that the percentage change in price was positive and the percentage change in quantity demanded was negative. So since I'm moving it over to the other side of the inequality, the percentage change in quantity is now going to have a positive number. The numbers on both sides of the inequality are now positive numbers. And the inequality tells me that the price effect, the percentage change in price, is bigger than the percentage change in quantity demanded. Now, divide both sides by the percentage change in the price of the product. And that gives you this fraction being less than 1. Now, does that fraction look familiar to you? Have you seen it before? You have. You have seen it before. That's the formula for the price elasticity of demand, the percentage change in quantity that results from a percentage change in price. That negative sign that we wound up with outside of that fraction, that does the same job that the absolute value sign did before. It just makes sure that the top and the bottom of that fraction have the same sign. That makes this a positive number. That's the formula for the elasticity of demand. And if it's less than 1, we say that the demand for this product is inelastic, like the demand for appendectomies. If that's the case, then price and total revenue move in the same direction. The company that has a product that has inelastic demand, when they raise the price of their product, what's going to happen to total revenue? It's going to go up. And why is it going to go up? Because the company is not going to lose customers. The customers are price insensitive. They stay with this firm even though the firm is charging a higher price. And because the price effect dominates the quantity effect, total revenue increases. Now, the opposite is going to be the case if we decide that the quantity effect is greater. If the quantity effect is greater, then total revenue is going to move in the opposite direction of the change in price. Again, the intuition is this. The firm may try to raise their revenue by charging a higher price, but what happens? What happens is all those price-sensitive customers defect. They go and buy some other product, some substitute product, or they just stay home. Because the quantity effect is so big, because this firm loses so many customers at the higher price, total revenue actually shrinks. And if you manipulate my equations like I did before, you'll see that the measure of elasticity in that case is greater than 1. That is our definition of a good whose demand is elastic.